Alright, so let's recap a few of the mechanics concepts and let's begin with motion. So if you notice, I've got a map here, right? And that's a map of Copacabana. Some of you might recognize it, right? And let's say that, well, we're here at this shopping mall, which is Rio Sul, and we want to get to the Siqueira Campus subway station. So there's loads of different paths that you could choose. So you could cross here, then just walk here close to this range of mountain range, and then you take this street just straight ahead until you hit the subway station. Another path that usually people take when they're driving, they can cross this tunnel here, and then they can go up Barata Barata Ribeiro Street. They can turn here and then turn again, and there they are. Or they could cross here if they have to. Another path could be going through Botafogo instead. So let's say a person's walking now, so they don't have to worry very much about the direction of the streets. And then there you go, you cross the tunnel here, and then you go up the streets, and there you go, and then you're done. So there are many different paths that you could take, and in each different path you would cross a different length. So the first concept, which is important for us to understand, is distance. And this is actually very basic. Distance is a scalar, and it's basically, well, between 2 points you can measure what's that length, right? That's the distance. So distance is a scalar, so it's just a number. There's no direction associated with it. However, when let's say that you go from one point to another one, so you're here on the beach and you go up to this point, so that could configure a displacement. So a displacement is kind of like a distance, but it's a vector. So usually we use letter S. Right, so displacement here, this would be our displacement, and then we could even work out, for example, if this is up to scale, we could see that, well, how many squares do I have here? So 4, how many squares do I have here roughly? So 4, 9, or 8, so around 8. So there we go, we could find out that our vector, in this case our displacement vector, we can describe this as, in this case, since it's left and down, it's -4, because it's, sorry, -8, which is to the left, and -4, which is down. So 4 down and 8 to the left. And we could also express this vector as -8i minus 4j. This is another notation of vectors that you should be aware of. Another concept which we could discuss briefly is our average velocity or average speed. So the average speed is the distance that you have crossed, that you have traveled, that you have walked, that you have driven, right, over the total time. So it's total distance over total time. Right, so let's take a look at a few examples. So we've got 2 examples here. In the first one, a cyclist travels 16 kilometers in 70 minutes. Calculate in meters per second the speed of the cyclist. So it's actually fairly simple. You should know that the speed, this is the speed, it's just average speed because nothing else is given. So it's 16,000 meters over 70 minutes. So 70 times 60 seconds. Remember to always keep units whenever possible in your SI units. So 16,000 divided by 70 times 60, that would be 16,000. Oops. So 16,000 over 4,200, so you can cross out some zeros. So this would be 3.8 meters per second. There you go. Now the second example here, the speed of light in vacuum is 3 times 10 to the power of 8 meters per second. A star is 22 light years from Earth. 1 light year is the distance traveled by light in 1 year. Calculate the distance of the star from Earth in kilometers. Well, if light travels 3.0 times 10 to the power of 8 meters per second, we could multiply how much it walks, how much it travels in a whole year. Right? So if speed is distance over time, if we rearrange that, we would find that the distance is speed multiplied by time. So our speed here is the largest in the universe, 3 times 10 to the power of 8 meters per second, and our time would be 22 years, because it takes 22 light years for that to happen, right? So 22 times, I've got 365 days in a year, I've got 24 hours in a day, I've got 60 minutes in an hour, and I've got 60 seconds. I won't be able to write this here. Times 60 seconds in a minute. That's going to be our multiplication here. So if we multiply all of that, we should find this distance to be 2.1 times 10 to the power 17 meters. And we could rewrite that, because we're being asked in kilometers, so we can just divide that by 1,000. So 2.1 times 10 to the power 14 kilometers. Now don't forget, in those questions we're talking about speed, we're not talking about velocity, because we're not defining a vector. For us to have a velocity, we will need some direction. For example, it could be 4.2 meters per second due north, or 55 kilometers per hour at 22.5 degrees from the horizontal line, something like that. Or you could even give a bearing